So welcome back again. Again, start from the beginning. This is paper chromatography. For the paper chromatography, we are going to separate a colorful mixer. The colorful mixer may be ink, maybe flower extract, or maybe any other extract of the natural things. Okay, so this is here colorful mixer. Maybe this consists of two compounds or more than two. We suppose here two. And also suppose that A is more soluble than B. So this we call relative solubility. Both of them dissolve in certain solvent, but A is more soluble than B. Suppose, okay, this may happen. And now we need the suitable solvent. Maybe this is water, maybe ethanol, maybe any other liquid. Suitable means this should be able to dissolve the compounds here, right? Dissolve the compounds. If you don't get water to be suitable, then you can use ethanol or any other solvent. Are you getting me? Any other solvent. So this may be question. This may be question. The water cannot dissolve one of the ink or one of the compounds. Suggest what to do there. Then you would say that change the solvent. Okay, change water, replace water with ethanol. Understand? Okay. So this is suitable, and you need a beaker. You need a large beaker, not small size beaker. For the chromatography, we need a big beaker. And what other thing you need? Anybody? Chromatography paper. Chromatography paper. Strip of chromatography paper. This is a special type of paper, not the paper for writing. Okay, this is the paper we write in. These papers are usually hard, non-absorbent. They cannot absorb water quickly. Okay, then tissue paper absorbs water quickly. So some papers like tissue paper, which can absorb water fast and also hard, or the hard, not like the soft, not soft like the tissue. Should be a little hard. Okay, so they are specially designed paper. These are available in the shop. So you need a strip of paper. Okay, so this is ready. Everything is ready for the experiment. I'm going to describe. What is the first thing we do? Number one, we draw a baseline here. Okay, we draw a baseline here with pencil. Draw a baseline. What the line we call? Baseline. And this should be drawn in pencil, because the pencil ink or the carbon doesn't dissolve in the solvent. Okay, so this is suitable. We need the line to be there. We need the line to be there. So we draw this in pencil. If you get in a question, if some students draw the line in ink, and the line itself will dissolve, may dissolve in the solvent, and there might be a question that suggests what to do or what's the wrong in the experiment. Okay, someone has drawn a line in the description of a question in the exam. This may happen. So someone has drawn this in ink, and you will be asked to identify the mistake the student has made. Okay, this should be drawn in what? Pencil. So this is first thing. What's the second thing we did there? We drop a single drop, just a drop, a small drop of the ink mixer here. Clear? A single drop. This is the number two. What's the third point here? Okay, so now the large beaker, this beaker, small amount of solvent, suitable solvent. Take small amount of suitable solvent in a large beaker. This is number three. What's the number four? Place this paper with the ink on the baseline. Place this in the beaker such a way that the baseline, where should be the baseline? Where should be the baseline? A baseline must be slightly above the solvent. The baseline must be above the solvent, right? Understand? And this is to prevent the ink to be washed away. Okay, prevent washing away. So we use the term wash away. Everybody got this? Wash away. So that doesn't dissolve. Don't write dissolve away. You can write dissolve away or wash away. Okay, just if you write only dissolving is a problem, that won't score any mark. Should the dissolve become mark pabena. So this is there, clear? So we put that there. What's the number five? What's the other thing we do? This is a lead, and lead is to prevent what? Prevent evaporation, so that the liquid doesn't evaporate or this paper doesn't get dry. Okay, clear? So when this is placed here, now you observe what you observe now. The solvent will move upwards. Okay, the solvent will move upwards slowly, and when the solvent touches the ink will start dissolving. Okay, ink will start. We already suppose that here are two compounds, A and B, and we already suppose that A is more soluble than B. So which one of these two, A or B, will dissolve faster? With A. So when A dissolves faster, then A will start moving up before B. Okay, after certain time, listen carefully, after certain time you will get that these two spot move upwards. The first one has greater distance A, and the second one less distance, travel less. They must be in the same line. These two spot must be at the same line, and when they move upward, here won't be any spot, right? Here there is no more spot because the spot, the ink mixer has gone above. Clear? So this thing will happen, and when you will stop the experiment, you need to stop the experiment. After a certain time, you will have to stop the experiment. Stop there, stop there. How to stop there? How could you stop the experiment? Yes, taking out the paper. Good. Taking out the paper. Okay. When to do this? When? At what point you will do this? When you see the solvent move upwards and it's very close to the top of the paper. Understand me? Understand? This could be a question. The when should you stop the experiment? This is when the solvent, which is moving upwards through the paper, when this is just close to the top of the paper. Clear? This shouldn't touch the paper. This shouldn't touch the top point.
What will happen if it touches the paper?
The next job is we have some measurement. Okay, if this touches the paper, then you won't have the information for the measurement. Okay, problem with the measurement. I'm coming there. So before touching this top, you will have to stop this. How to stop this? Just remove this. Okay, after remove this, you put it to dry. This is there again. Look at the paper. Here was the baseline. Here was the ink drop, but this may not be there, right? This may not be there anymore. So what do you get here? A and B, right? Two spot. What does the two spot mean here? Two spot means there were two compounds, right? Two compounds mixed together. If you get three spots, three different colorful spots, which mean there were three compounds mixed together. If you get four compounds, then there were four compounds mixed together. Understand? So with the number of spots or number of drop there, we understand how many compounds were there. Clear? Everybody clear? And now after you get this, after you remove this, you just need to draw another line here. Another line. Quickly draw another line. This is for the indication of the solvent front. Understand? I was talking about the solvent front. Before the solvent front that's moving up, before this touches the top, you should stop this. And this is the point. Because when this will dry, you won't get the solvent font. Okay, that will be missing. So you just draw with pencil to indicate this is a top of the solvent, right? Solvent, okay, font, move up to this. So this is there. So I write here, this is here solvent font. Okay, then this is the baseline, it's still there. Baseline, this is still there. And here is A and B. Okay, A and B. So now leave it for drying. Just leave it for drying. This will dry in some minutes. And when we dry, then you can have some more measurement. Look carefully. This is more important now. The experiment is finished. The paper we get now is called chromatogram. What do you call the paper? Chromatogram. Colorful points there with the lines here. We call this chromatogram. And the chromatogram we can use to identify the A and B. Understand? Identify. We have already identified there are two compounds. Okay, but which compounds they are, that you can identify. Understand? So this is a physical test, like physical test. Suppose a liquid is in your hand. You have a liquid. You have a certain liquid. Can you identify which liquid is that with a physical test? We already learned this. Come on, we already learned this. Can you identify, carry out an experiment to identify which liquid is that? How? How? No, you just boil the liquid. Okay, you measure its boiling point. If you have a liquid, you heat to boil the liquid, and then you will measure the boiling point. Are you clear? You can measure the boiling point of the liquid. Okay, and the boiling point, you know, you can match or search in the Google which compound boils at this temperature. Understand? Suppose the liquid is water, then you would get the liquid boils at 100 degree. If the liquid boils at 100 degree, you identify the liquid is, what is the liquid? Liquid is water. Liquid is water. And if you get another liquid at boils at 78 degree, so what is the liquid there? Ethanol. So this is how, by measuring melting point or boiling points, we can identify compounds. Understand? So here I'm talking about A and B. Similarly, with this experiment, with some measurement, we are going to identify A and B. You clear? A and B can identify korte jacchi here with a simple measurement. What is that? What the measurement we call? This is called RF. This is called RF. Retardant factor. Retardant factor. Retardant factor. This is called. We just simply measure this. Khub sahoj jinish. Don't worry about this. This is a ratio. This is a ratio. This is a ratio of two distance. Distance of a spot. Understand what is that? Distance traveled by a spot. Suppose here A has traveled a certain distance. If you talk about A, then what the distance A has traveled? Measure kora jabe na scale diye. Understand, when you have this dry paper and you have a scale, can't you measure the distance traveled by A in centimeter or in millimeter? Parbe na measure korte. Okay, can you measure the height of this or this part with the scale? Parbe na. So similarly, when you have this, starting from baseline, you will have to measure the distance traveled by A. Clear? Isn't this simple? Simple? You can do this. Okay. So this is distance by a spot. This might be A or B. We are talking about now A. Now, when you measure distance, this should be at the top, up to the top of the spot. Not at bottom, not up to this. This should be up to the top. Clear? For measurement. In exam, you may have to measure this distance with a scale. Now another distance by of the solvent. This is basically, I say, distance traveled by a spot and divided by distance traveled by the solvent. This is here. What is the solvent? Look. Clear? So why do you need the two lines? Understand now? You need these two lines. I told you before the experiment, you have drawn this in pencil, and the line is still to be there. Line should be there. Line should be there because we need this now. And after this, after the experiment was over, we again drawn the line, another line. This to indicate the solvent front. Clear? So we now measure these two distance. This is distance of the solvent front. This is traveled by the solvent front. And another is distance traveled by any of the spot. Okay. Can you get the values from this? এই পেপার থেকে ভ্যালু বের করতে পারবে না? পারবে না? এই বলো পারবে কিনা? You can get the values here and put the values and the value may be here. This is shorter. 3.7 and maybe 4.8 centimeter. Suppose I write. Suppose this is, and you get a value. What is the value you get here? Some value you get here. Some value. Now go to the Google. Search in Google which compound has the value of RF. This retardant factor. I told here retardant factor. Okay, RF is a property, is a physical property. It's like melting point. It's like boiling point. Suppose water boils at particular boiling point. What is that? 100. In nature, only water boils at 100 degrees. Only, I say only. No other substance boil at 100 degrees. It had a fixed particular property. Water a particular property, water 100 boil could. And another compound boils at another temperature. So when you're measuring RF, RF, this compound has a particular RF. This compound has different RF. And many other compounds, they all have different values of RF. Clear? So when you estimate RF for A, this has a particular value. And now the value to be matched with the data booklet or in Google. Data booklet bozo. Data booklet is a book containing all the compounds with their respective RF value. Understand? Understand? There are many values of RF given and the respective compounds are also given there. So with the RF value, you can identify the compound there. Understand? With the value, you can identify the compound there. And you can search in Google. This is very simple that you search which compound has this. You have RF value. You don't know the compound, right? When you have calculated this RF, then you have RF value and you need to know which compound is this. Just search in Google which compound has this value. You will get name of the compound. Later. First, let me finish this. This is RF, okay? This, you can see this. If you look at this, this is total explanation is here. RF is a ratio between two distance. How far a compound travels divided by how far the solvent travels. This ratio is called RF. RF is a particular, for particular compound, the RF has a particular value. And all the compounds will research on or will have different values of RF. Understand? So matching this experimental value with data booklet or in Google, we will identify which compound is that. Understand? So this you may get. And can you calculate the RF value for B too? B এর জন্য RF এর value calculation করতে পারবো? বলো, পারবো কিনা? পারবো না? So what is that? বলো দেখি, কি বলো দেখি? The distance traveled by B. Understand? The distance traveled by the spot B and divided by distance traveled by the solvent, still solvent. So this gives a ratio and RF value is the distance traveled by B divided by distance traveled by. তো মনে হচ্ছে তাকিয়ে আছো, দেখতেছো না, চোখ দেখে ভাব মনে হচ্ছে distance traveled by, হ্যাঁ distance traveled by তাসফিয়া বলো সলভেন্ট, হ্যাঁ ওই যে বলছো আমি চোখের দিকে কেউ এরকম করতে করতে অন্যদিকে চলে যায়, এটা আবার দেখা যায়, চোখের দিকে তাকিয়ে দেখা যায়। So distance traveled by spot particular compound divided by distance traveled by solvent. So you can estimate the value of RF for B and for other compounds too. যদি অনেকগুলো কম্পাউন্ড থাকে প্রত্যেকে RF ক্যালকুলেশন করতে পারবে? পারবে? পারবে। Okay. And from the values you now match with the data booklet or Google to identify them. আর কোনো কোশ্চেন থাকলে ask me. You have question?
Yes, sir.
No question?
Sir,
হ্যাঁ, yes. অনলাইনে বলতেছো না?
sir, দুইটা ইঙ্ক মিক্সচার কি সেম সলিবিলিটি হইতে পারে?
শোনা যায়? You get? আচ্ছা, এখানে একটু প্রবলেম হচ্ছে, আমি শুনতে পাচ্ছি না। আবার বলো।
স্যার দুইটা ইঙ্ক মিক্সচার কি সেম সলিবিলিটি হইতে পারে?
না না, হতে পারে না, এটা হতে পারে না। Yes, I got the question. Two compounds never have same values of RF. যেমন বয়লিং পয়েন্ট দুটো কম্পাউন্ডের কখনো এক হয় না। Understand? Two compounds, two separate compounds, ওয়াটার, ইথানল, এটা সেটা অনেক কিছু আছে, আবার বয়লিং পয়েন্ট আলাদা এবং রেকর্ডেড। সব কম্পাউন্ডে RF ভ্যালু রেকর্ডেড থাকবে। As the boiling points are recorded, RF values will also be recorded. Clear? Are we clear? So now, so see here the note again. The procedure: a drop of concentrated dye mixer. Concentrated dye mixer is placed where? Where do you place this? On the baseline. Clear? On the baseline. And then what's that? The paper is then placed in a suitable solvent. We place this in suitable solvent in a beaker. Then this condition is the drop should not touch the solvent. বলো তো জিদান, টাচ করলে কি প্রবলেম হবে? আফিফ বলো, শোনা আফিফ বলো কি প্রবলেম হবে, টাচ করলে কি প্রবলেম হবে? Will be wash away. Yes. Next number is the container is then covered with a lid. কেন লিড দিয়ে কভার করতে হবে? না করলে কি প্রবলেম হবে? Evaporation হলে experimental error চলে আসবে। Okay, now the dye component which is more soluble dissolves more quickly and travels at faster rate. Okay, so more soluble component travels greater distance along the paper. Okay, the different spots of the separated components produce a chromatogram. Ultimately, you get the colorful things chromatogram like this. Look at this. You see this? This is baseline. This is the paper, and this is put here in the solvent. This is solvent. This is just above. This is just above the solvent. বলো তো above না হলে কি সমস্যা হবে জিদান বলো তো? টাচ করলে কি প্রবলেম হবে? Wash away. Will wash away. Okay. So cover with the lid and now get this. দেখা যায় কালার আলাদা হয়ে গেছে মতন না? Clear? Solvent, separated component, solvent front and flow of solvent. না এখন আমরা এখানে তিনটা অবজারভেশন পেয়েছিলাম বলো তো দেখি কেউ তিনটা অবজারভেশনস we got three observations in last class we discussed বলো তিনটা অবজারভেশন পেয়েছিলাম বলো the paper chromatography paper will be wet and then number 2 a less solvent, yes, so amount of solvent will decrease. Number 3 another observation, yeah, so one observation about the paper ভিজে যাবে, another observation about the ink solvent ink mixer সেটা উপরে যাবে সেপারেট হবে, another observation about the solvent সেটা কমে যাবে। এটা তো জীবনে ভুলে যাওয়ার কথা না, কি ঠাসকা লাগে বসে থাকলে তো হবে না। Okay, I told that in last class. Again, if you need, then, and I've been telling this also now. Okay, come on here. Observations: the paper, chromatography paper becomes wet, right? Wet, and then dye sample moves upwards and gets separated. Okay, and amount of solvent will decrease, and then RF. Look at the RF. How to get this RF? দেখা যায় RF কিভাবে পাওয়া যাচ্ছে? এই যে এইটা তোমরা নিশ্চয়ই ভাবছো, some of you are thinking এটা তো মনে থাকবে না, রাইট? ভাবছো না? এটা মনে রাখতে হবে না, এই ফর্মুলাটা তোমাদেরকে এক্সামে দেওয়া থাকবে। Is this okay now? Are you comfortable now? এই ফর্মুলাটা দেওয়া থাকবে, এই যে ডায়াগ্রামটা এটাও দেওয়া থাকবে। তোমার কাজ কি হবে? What the thing you will have to do বলো? এই যে এইখান থেকে এইখানে কতদূর গেছে স্কেল দিয়ে মাপতে হবে 8.5, and এই যে সবথেকে বেশি দূরে গেছে যেটা কত দূর গেছে এটা মাপতে হবে, যেটা শর্টকাট। Okay, right. Okay, right. Here the formula will be given and distance 8.5, distance 5.8 and distance 3.8. Accordingly you get RF. RF দেখো তো বসাচ্ছে কিভাবে, দেখো 5.8, what is that? 5.8 traveled by solvent, and what is the here 5.8 traveled by this compound 8.5 traveled by solvent. Now get the next one RF for the other compound, the name of the compound here, name of the compound. 3.1, look at the 3.1 and 8.5 is the total distance of the solvent. Clear? And this could also be like this, this is another diagram to show you. Okay, this also, and okay, there's no more now, and next day in the next class we'll have some practice exercise করব ক্লাসে বসে। সবাই clear? So this is finished here up to this, and next day we'll have some practice ক্লাসে বসে আমরা কিছু প্র্যাকটিস করব on this chapter, on this topic, chapter না টপিকের উপর, তারপরে আমরা টেস্ট নেব। So thank you very much everybody. আর যদি কোনো কারো কোশ্চেন থাকে you wait and I'm going to explain. Thank you online, মাত্র 2 জন হয়ে গেছে।